Okay, thanks. So thanks, Rhina. I think you already took my part because I'm only introducing the studio, and the main work will be done by two of our students. What the studio has mainly been doing in the last couple of years is trying to investigate digital methods for parametric design in architecture and urbanism. We are doing this because we have the feeling that some of the other, maybe more traditional design methods do not necessarily always reflect the, let's say, contemporary complexity of society. Let's leave it at that. As far as we're concerned, architecture and urbanism is always the result of like a multitude of different forces and influences, and they all act simultaneously on the built environment. And this is why what we are trying to do is we're trying to develop digital methods, actually, or processes, as it were, in order to be able to set up parametric models that can react and interact with all these different internal and external parameters that seem to be important to us. And in the last couple of years, we've been taking that thing through a couple of different scales and stages, from the urban stage to the building and high-rise cluster scale, to the building and component scale, and also to the interior scale, and always looking at the same type of things. Most of that things are actually on display at the exhibition in the other buildings, so we thought it would be nice to present something more recent, something you have not been seeing so far here now. And in the last year we have been returning to urbanism, actually, trying to rethink again urban design strategies, and exemplifying that with two cities which are facing right now very huge infrastructural projects. One of them being London, with their plan of creating a new airport hub to the east of London, and the other one being Istanbul, with their idea of creating a new canal connecting the two seas next to the city. So this year, the entire studio is basically subdivided in two different big groups of students, one of each tackling each of the cities. And I'm basically now handing over the whole thing to two of our students, and they will, I think, be happy to introduce you very quickly to the work in progress, which is being done in the studio right now.
So I am Aleksandra Mnich, and I am representing the London team. And so, as Robert said, the context is the London airport, which is planned on the Thames estuary, and where we also can observe like high intensity of the movement because also of the planned train connection, like high-speed train, underground train. As a consequence of all this infrastructure, like important factor and environmental factor on the site is the noise emission of all of those infrastructures. And like just for kind of quick comparison, like the level of noise which announces annoyance in the population occupying the space is like 57 decibels. So as you can see, the noise is basically covering almost the whole area, which will be like a kind of challenge for us to deal with that. As a next factor, what is also like a global kind of condition within the site is the proximity to the water, and which is kind of like giving us like opposite, like attractive value of a view on nature. So as a first step, we analyzed all these connections leading through, like going through our area, and we picked the existing stations as a kind of seeds for the growth of our infrastructure, because we decided, like, just because of the kind of intensity of transportation infrastructure in here, that our primary layer organizing would be the public transportation network. which grows according to the rules of walkability, of like how much people are actually willing to walk towards the station, the spacing in between them, and the speed hierarchy of different modes. And also the interesting part is that we interconnect them, so one grow from another one, which provides a kind of continuity of the whole network. So this is already grown one, and you can see that it's a like network within the network within the network, like having the hierarchy. And then we try to find the information what it already gives us to inform the other layers of like other programs. So for example, we could analyze the like physical distance within the network, which like defines the physical centrality of the whole system, and the number of connections. So for example, to how many connections you can get within like one node. And third parameter could be a time, which is related to the speed hierarchies of all of those modes. And the last one is a node depth, which we call it which defines how direct the connection is, and like through how many of stops you have to actually go. And then so the information delivered from the analysis let us establish the stops hierarchies, which changes according to the parameter we choose. And then with that information, we want to inform our program distribution. So we want to establish the relationship of the program towards the certain parameters of the transportation network. And then as additional system, we introduce like the values from the analyzers are interpreted by the directional field, which lets us arrange the distribution and creates like various local conditions within the field. And here you can just see the tryouts we made, like to kind of establish the values we would assign to different nodes. And basically here you can see like these various conditions it creates if we apply if we distribute the program along those lines. So we have like kind of local changes of densities and directionality, or different kind of grouping of them. So then we actually we create the field for each typology. So here you can see the residential typology, and each of these fields takes a different map as an information source. So each of them has different directionality. So for example, here this is like just a cutout from the whole site, just so you can see that we assign the informations program would interpret. So for example, for residential, we say that the node depth map, as well as the connection and the water map, would define areas of where the housing typology is distributed and how it's already attached to its pattern. That's the office. So for office, we took noise map as a attracting value, a connectivity map, and like the physical distance maps. That's the retail map. Again, interpreting different parameters derived from the analysis. And then in the end, you can see like an overlap of those. And what we're trying to do now, this is basically like superposition of all of those layers, and now we're trying to integrate them within each other to create more relationships. So it's not a superposition anymore, but they're kind of starting influencing each other, and yeah. So Hello, my name is Rhina. I represent in the Istanbul group. We have a completely different situation. We are dealing with Turkey, is the area of development, and they are planning to make a canal. So our city will be developed to follow the canal. And we have already like a linearity established, so we start making a research of different linear cities, and the first one was dated in the 1882, and it's Arturo Soria and Spanish urbanism, and he wanted to link two cities, and this idea evolved. The next one, 1910, Edgar Chambliss, he started to stack, and then so on. There's like more radical examples in the continuous city. They want to connect the West and the East in America, and most of them they are trying to. They end up creating a megastructure in this linearity and more trying to look more in the functionality. And the most recent example we found out was in 2008 from Roder and Partners, and it was in Paris in the periphery, and it was like an underground connection between a city and a new development. And then we start with our project. So because there's no a canal yet, so we need to find a placement for a canal. So the first one is the canal path, and it's trying to look for a path that is a comfortable navigation for the boats, and also trying to have the less amount of soil removal. And parallel to that, we also assign like a city development area that we call the city boundaries, and it's not following completely the canal, it's following the topography. So sometimes when the topography is more flat, we can spread more, and sometimes it's going in one development in one side of the canal, or when it's the mountain area is kind of getting compressed, kind of this megastructure idea that we saw in the past. And briefly, we start with site data and our development map, so where the canal is going to be and our transportations, and then we assign potential locations, so we create criteria with the two first sets to where the systems could be placed. And we also overlap the systems, and we find new typologies, new mixing of programs, and then we assign a formal language. So this is the site data. We always reparameterize in a gradient map, so that allows us to be able to compare like high soil radiation or a high inclination of the topography. And these are the development data that we create. So where is the city growing in related to the canal, and how extend could it be, because some programs need to be closer to the canal or extend a bit further. This is our transportation system, and we decide to have side canals. They are branching from the main canal, and they are attracted to the coast, and they're mainly to decrease the traffic and also to create to bring this canal idea, but in a smaller scale, for example, for residential. And we also have a high-speed train, because maybe it's not linear like in the past, but we think it's important to be able to connect the north and the south of our city. And we have a highway that's connecting to the existing nodes, and we have a metro that's trying to connect both sides of the canal. And the last one is the secondary roads. That is the compressing when it's less density, and it's getting more space when it's less density. The other way, sorry. And okay, so these are our systems, and there's like a hierarchy. And housing and work are the primary systems, because they are placed first, and they also just react to the data of the site, and also to our development maps. And then our secondary system, like educational culture, are already taking in consideration where work and housing will be, and then so on, retail and recreation are following all the other ones. And just one example, because every system has its logics, but just to show you briefly how can we create a criteria to place residential. So every has like 3 subsystems. For example, we think in a terrace housing that needs to have a certain inclination, so we look for a certain inclination, to have solar radiation, and then to be closer to the main canal. So these three criteria give us the first map. So this is what this type of housing could be placed. And then the tower have a completely different criteria. They can be farther away from the canal. They still look for for solar radiation. And then the villas are looking just to the side canals, solar radiation, and they can even spread more from the canal. And these are the three types separate and then overlay between each other. And then we always, because we have a lot of different situations within the linear city, so we always bring closer three of the stream situations. So the mountain city, you can see like the program is always condensed in the middle, and the city across the plains is like growing in one side, and the coastal city is spreading in both sides. So that's why we make this sum up to be able to get a feel of what is happening in this overall. And these are all the systems, so that basically for each one of them we made three subsystems, and they have their own logics, and the overall is the final image. Okay, so before doing that, we already have some work done in the previous, so we already have ideas of what a villa, or like the basic ideas of how much they could connect, or if they should be linear or more looping. So we have this catalog from last semester, and we wait. Okay, this should be something in this one, but it's coming. So okay, this is our city, how it's looking, and what we get. It's not appearing, but what we get is this overlaid program. So it's the first one, and then through that we carve with the transportation, and then in the third one you can see how different programs are on top of each other. So then we create new typologies from the catalog, and then we know we still need some more detailed patterns, like street patterns, but we jump to the three scenarios and we bring this formal language. So this is the coastal city, so this is the bottom one that is spreading in both sides of the canal. Okay, this is a perspective view of the coastal, and the next one will be, one is just growing in one side of the canal, and there's like a perspective. That's it. Thank you.